Hi, how is it going? Welcome to Code with Z. Today's question is LeetCode number 13, Roman to integer. In this question, we're basically given a string and we gotta convert it to its integer form. And we're given a bunch of rules that we can actually use to kind of do this conversion. For example, the letter V means 5 or X means 10. However, there are a bunch of edge cases that we gotta cover that are mentioned here. I'm gonna visualize and explain all of this process in the slides, but just for the sake of reading the question itself, let's see what these edge cases are. As you can see, it says I that represents 1 can be placed before V, which represents 5, and that's gonna give us 4, meaning IV is equal to 4. And if we place I, which represents 1, before X, which represents 10, it's gonna give us 9, meaning IX is gonna be equal to 9. So we gotta cover this edge case that if a letter is placed before another letter, it might change the rules that we have up here. But don't worry, we're gonna solve it together and I'll visualize the whole process for you. Alright, let's say we were given this Roman number and we gotta convert it into its integer form. And we're also given this object or table that we have here that basically tells us what value each symbol represents. So we were given these two and we got to return an integer, right? So for doing that, let's first of all have a result variable so we can actually store our result here and then return it at the end. And then let's actually use what we were given. As you can see, we see an L here. And we do see an L here as well, like so. So we see that we can say, because we have an L here, and in this object it says that L is equal to 50, we could just say add 50 to our result because we have an L, right? And then we can move on to the next one and we see that we have a V here, and here in our object it says that V is equal to 5. So why not just add 5 to our result and move on to the next one? And then we see that we have I, and I is equal to 1. So we're gonna add 1 to our result and move on to the next letter. And that's gonna be again I. We're gonna do the same thing. I is representing 1, so we're gonna add 1 to our result, and then we're gonna move on to the next one. And again, same thing, we're gonna add 1 to our result, and this is our answer. This string here is equal to 58. So this is the integer version of our Roman number here. So as you saw, we use this object here to solve our problem. But what if we have a number like IV? Well, if we do the same calculation, we could say that I is equal to 1, like you see here, and V is equal to 5. So IV is gonna be equal to 6, right? But this is actually incorrect. In the Roman number, IV is equal to 4. And that's because I is placed before this V here. V is representing 5 and I is representing 1. Because I is placed before this V here, we're gonna say the value of V, which is 5, minus the value of I, which is 1. It's gonna be 5 minus 1, so that's gonna be 4. But we need to find a way to cover all of these edge cases simply, right? Because for example, LX is equal to 60 because L is equal to 50 here, and X is equal to 10. 50 plus 10 is gonna be 60. But on the other side, XL is gonna be equal to 40 because L is equal to 50 and X is equal to 10. And we gotta subtract 10 from 50, so that's gonna give us 40. If we take a look at this, we can actually get to some kind of a conclusion. As you can see here, L is representing 50 and X is representing 10. And the bigger number, which is L, comes before the smaller number, which is X. But here, we have the exact opposite. The smaller number comes first, and then the bigger number comes. And when the smaller number comes first, we actually subtract its value from the bigger number. For example, L is 50 and X is 10, and we say 50 minus 10 is equal to 40. So we can actually say if the letter that's representing a smaller number comes first before the bigger number, we could actually just subtract its value from whatever result that we have here. I'll visualize this so many times in the next slides that you'll never forget this in your entire life, so don't worry about it. But just know that if the smaller number comes first, we're gonna subtract its value from the overall thing that we have. Alright, let's visualize it together. So first, let me show you our simple algorithm. In our simple algorithm, we're gonna have a for loop, and inside of it, we're gonna only have 4 lines of code. The first line is if the value of our current character, for example, if our current character is M, and its value is equal to 1000, as you can see here, is smaller than the value of our next character. For example, our next character is gonna be C, and C is equal to 100. So if 1000 is smaller than 100, do the following. If it was true, meaning if the value of the first letter was smaller than the value of the next letter, we're just gonna subtract the value of our first or current letter from the overall result that we have. Just like I mentioned in the previous slide, and don't worry, I'll visualize the whole algorithm for this string here, so I make sure you fully understand it. These are just examples to kind of explain the algorithm. And if this was not true, we're just gonna add the value of our current character to our result. And then at the end, we're gonna return our result. This is all of our code. Now let's get to the fun part, which is the visualization. As you can see, we have a loop and we're gonna loop through each letter in our string. So let's start. We're gonna be in the first round of our loop, and in our first round, we're gonna be pointing to this letter here because that's the first letter in our string. We're gonna say if the value of the current character, as you can see, we have M, and the value of current character is gonna be 1,000. So we have 1,000 here, is smaller of the value of the next character. As you can see, it's gonna be C and 100. So if 1,000 is smaller than 100, it's not. So we're gonna fall inside the else. We're gonna say the value of the current character, which is 1,000, should be added to our result, which is 0 currently. And let's just do that. And as you can see, result is equal to 1,000. And then we're gonna move on to the next round. As you can see, we're in the second round now, and our current character is gonna be C. So we're gonna say if the value of the current character, which is 100, as you can see, we have 100 here. So let's do that, is smaller than the value of the next character, which is M, and 1,000. Is 100 smaller than 1,000? It is. So we're gonna get inside this if statement and we're gonna say result is equal to result minus the value of the current character. So result is currently 1,000 minus 100, and that's gonna be 900. And then we're gonna move on to the next round. In our next round, our current letter is gonna be M. So we're gonna check again, is 1,000, which is the value of M, smaller than the value of the next character. Our next character is X, and X is representing 10. So is 1,000 smaller than 10? No. So we're gonna fall inside the else, and we're gonna say result is equal to result plus the current value, and that's gonna be 1900. And then we're gonna move on to the next round. We're currently in the fourth round. So let's do our calculations again. The value of our current character is 10, and the value of our next character is 100. As you can see, 10 and 100. Is 10 smaller than 100? It is. So we're gonna get inside this if statement, and we're gonna say result is equal to result minus the current value. So it's gonna be 1890 because we just subtracted 10 from 1900. Then we're gonna move on to our fifth round. In our fifth round, our current letter is gonna be C. C is representing 100, and our next letter is gonna be I, and that's representing 1. So is 100 smaller than 1? It's not. So we're gonna add the current value, which is 100, to our result, and that's gonna give us 1990. And then we're gonna enter our sixth round. In our sixth round, our current character is gonna be I, and that's representing 1. And our next character is gonna be V, and that's representing 5. So is 1 smaller than 5? It is. So let's actually get inside our if statement and do our calculation again. 1990 minus 1, that's gonna give us 1989. And then we're gonna move on to our final round, and our current character is V, and that's representing 5, but the value of our next character is going to be undefined because V is the last letter in our string. So we're going to say is 5 smaller than undefined, and this is going to be false, and we're going to fall inside the else, and we're going to add our 5 to our result, and that's going to give us 1994. And that's our answer. We could actually do something to kind of ditch this undefined, but it's going to add one line to our code, and this version works perfectly and it's simpler to explain, so we went with this approach. And then we're going to break out of our loop and return our result. Now let's code this in the simplest way possible. All right, so first of all, let's define our result variable. That's going to be equal to 0. And don't worry, I won't waste your time and make you watch me type this out, so I'll just copy paste it. As you can see, it's going to be the same thing. I is equal to 1, so I is equal to 1, V is equal to 5, and so on and so forth. I called it symbols to value, and it's an object, as you can see, and it just has the information that was given to us by the question itself. And then we're going to create our loop. So for let I is equal to 0, keep on looping as long as I is smaller than s dot length. And this s here was given to us by the question itself. It's actually the string that we are converting into an integer. So let's go down. So I plus plus, and this is gonna make sure that we loop through each character. Let's bring this down a little bit. And then we're just gonna have our if statement. We're gonna say if symbols to value of s of I, meaning if the value of our current character is smaller than symbols to value s of I plus 1, then the value of our next character, do the following. Result is going to be equal to result minus symbols to value of our current character. So we're actually subtracting the value, as you can see, of our current character from our result, just like we saw in the slides. And else, we're gonna say result is equal to result plus symbols to value of s of I. And here we're just adding the value of our current character to our result. And this is literally it. And then at the end, we're gonna return our result. This is all of our code. Now let's run it and see if we're gonna pass our tests. Yep, as you can see, all 3 of them are passed. Now let's submit it. Moment of truth. Drum roll, please. Just kidding. Yep, as you can see, we're accepted and we're actually beating 84% of all of the other submissions. And that's awesome. Thanks for watching and don't forget to like and subscribe. Keep on coding.